Hey everyone, let's look at recursion. It's possible for a function to call itself, and this is called recursion. So let's consider the example where we want to compute the factorial of a number. So the factorial is defined as n, your number n, exclamation mark, equals 1 times 2 times 3 times up until that number n. So for example, 5 factorial is equal to 1 times 2 times 3 times 4 times 5. Now one way to solve for this is using a for loop. So let's define our factorial function, which will return an int, factorial of int n, open curly braces. We're going to initialize our result to equal 1, and we're going to loop through for loop with the first expression, int of I equals 1, until I is less than or equal to n, and we increment. And we open our curly braces, and our result is going to be a result value multiplied by I. Finally, we want to return our result. So return result. And let's say I wanted to take the factorial of 5. I would do factorial of 5. Run that, and factorial of 5 returns 120. So now let's say I wanted to run the same function but in recursive form. And the way I can do that is define int factorial r for recursion. It also receives int of n, open curly braces, and if n is equal to 1, then this is what I'm going to call our base scenario. So we're going to return 1. Otherwise, we're going to return our n times factorial. So we're going to call our factorial function and provide the value of n minus 1 that we received. So our factorial function received n, and if n is not equal to 1, then what we're going to do is call our recursion function to calculate the factorial for n minus 1 and multiply that with n. If I run that, I'm going to call the same function. I'm going to also add a new line, so our printouts are neat. So I'm going to call factorial r, which is the recursive form of our factorial function. I'm going to run that. And as you can see, it ran just fine and returned the same value as our standard factorial function. So that's how we can define a recursive form of a function call. And basically what's happening is best explained by this diagram. So what I'm showing you here is the function that we were working with. So int factorial of r, this is our recursive function at the top, and then we have our main function, which is calling factorial r of 3. So what happens when we run this code is that the first thing the processor does is checks for the main function, and adds that main function to the stack. So stack is a process that's happening behind the scenes to keep track of all the operations that are happening on the system. So main gets put on the stack, and then factorial of 3 is called. Factorial of 3 is put on the stack. The next thing that happens is the value of 3 is passed to the function, factorial r. That processing starts to happen. So once the value's been passed to the function, the condition statements are checked. So first, if of n equals 1 is checked. Now n is actually 3, so this condition is going to be false, and so we'll jump to else and execute what's the code that's within the else block. And so the code here is return n times factorial r of n minus 1. So there's another call to factorial r. That's call to that function factorial r gets put on the stack, and the argument of n equals 2. So we had n was equal to 3, 3 minus 1 is 2, so the argument n equals 2 is passed back to factorial r in a recursive manner. And so 2 comes through, the condition, the if condition 2 equals 1 is compared, it's false, and then again we come down to the else statement, and the code block that's within the else statement is going to execute. And in this case, factorial of r of n minus 1, 2 minus 1 being 1. So that function call gets put on the stack. It gets put on the stack as factorial r of 1. N equals 1 is passed back to the function. We come through again with now n equals 1. N in this case, in this if condition, is actually true because n does equal 1. 1 is returned. So we've reached our base condition. 1 is going to be returned. Our function on the stack can finally return a value. It returns a 1 back to the next function on our stack, which is factorial r of 2. This call is now removed off of our stack. I've hidden it away. We go to the next function on our stack, factorial r of 2. That would be here. So factorial r of 2 is a value of 1. So 1 times n being 2. So 2 times 1, it returns the value of 2 times 1 back to the next function in the stack, which is factorial r of 3. Factorial r of 3 is 3 times 2 times 1. That is returned to our main function. So we finally finished all our recursive calls, reached our base condition of 1, and returned it back up, or back down our stack rather. Return 2 times 1, returns 3 times 2, and then we're back to our main function, and we've finished executing all the recursive calls. So that, through a diagram, is how you could think of recursive functions. You could actually try to very simply map the calls and also draw them on a stack. That is what's happening behind the scenes.